In today's lesson, we are going to look at solving quadratics. So this is going to be our last unit on quadratics, and we're going to look at now more application questions using the different forms and using the different concepts that we've looked at previously. So to start off, the equation representing the path of a cliff jumper, h at t is equal to negative 5t squared plus 10t plus 15, where h is the jumper's height and t is the time in seconds. So when does the jumper reach his max height? Oh, got the pronouns kind of jumbled up. When does the jumper reach his or her max height, and what is his or her max height? So in this kind of introduction, we're not going to worry too much about actually calculating any of this. We just want to be able to we just want to be able to, if we were to graph it or plug it into Desmos, can we determine this information? So if I'm looking for when they reach their max height and what is their max height, I'm going to look at my graph here. So I've already created this graph. The y value is going to represent our height, and the x value is going to represent our time. So the height is our y, the time is our x, and we're asked when do they reach their max height? In this case, if I look at time, the maximum height is here, and the coordinates for that are 1 and 20. So that means they reach their max height at 1 second or after 1 second. So reach their max height after 1 second. And their max height is 20 meters. The other thing we're going to look for is when do they hit the water? So if we imagine that our cliff diver, right, is starting up here, right, we'll just draw a little stick figure. They jump into the air and then they dive off the cliff. Right, so we want to think, when do they hit the water? In this case, we're going to be looking for when the height is 0. Right, so they hit the water, their height equals 0. So in this case, their height equals 0 after 3 seconds. Height equals 0, or we could say we're looking for an x-intercept. Now you could argue, well, there's an x-intercept back here, but does it make sense that they hit the water at -1 seconds, right? So in this case, that doesn't really make sense, right? So even though our parabola can go into the negatives, realistically, we're only looking from 0 and forwards, right? So again, in these types of scenarios, because we're dealing with an actual application, we have to consider what values are actually true or what values actually work. Right, so we can't have negative time, so anything beyond 0 doesn't count. Or not that it doesn't count, it's just not considered. Now, what if the question was at what time is the jumper 15 meters in the air? Right, so before, we were looking at our equation, and essentially now this means we want to know for what value of t does the function equal 15? So essentially what we're looking for is 15 is equal to negative 5t squared plus 10t plus 15. The new thing now is we're trying to say this function is equal to 15, or when does it equal to 15? Now, if we wanted to, we might have to solve algebraically, find the values of t that work. But right now, right, we're just going to be using a graph. So before we found the t values that made the function equal 0, right? So that was one of the questions where when he hits the water. Or we'll just say when they hit the water. So that meant we had to find the zeros, right? So that was what our previous question, we were looking for when the height is 0, or we were looking for the zeros or the x-intercepts. Right? Now what we need to do is we need to find out for what t-values the parabola is equal to 15. Right? So that's when we change this question. We're looking now, when is the height 15? So if I go back up to my graph, there's 2 points, right? Height is the y value. So where do I see a height of 15? I see one here and here. So at 0 seconds and at 2 seconds. So what does this mean? Well, this means that they start on the cliff, which is 15 meters up, right? Because when the time is 0, the height is 15. So at 0, that's where we're still on the cliff. And then we jump off. And then the second time they're at 15 meters is after 2 seconds. So then they reach 15 meters again after 2 seconds. So in some cases, we might have 2 times when we're at a specific height, right? Again, that's part of the parabola, that U shape, right? So we might be jumping up, reaching a certain height, and then when we start to come down, we pass through that same height again. Next example, so student council is selling cases of gift cards as a fundraiser. The revenue Rx in dollars can be modeled by the function R at x is equal to negative 25x squared plus 100x plus 1500, where x is the number of cases of gift cards sold. So the first question is asking, how many cases would the student council have to sell to make $1,375 in revenue? Now in this case, right, if we were to graph it, that's a pretty specific value. That's a little bit harder to tell, right? So again, what we can do, even though we have the graph here, it might help us for some cases, but if we're trying to be very specific, it might be helpful to graph in Desmos. So if I go to Desmos and I bring up my graph, right? I can, or my graphing calculator, I can go back and actually, let me just sum this up. I can enter in my equation here, negative 25x squared plus 100x plus 1500. Now, can't really see much of the graph, but I can zoom out. All right, let's change this up a bit, just because it's a little bit too big. So I'm going to go over my graph settings, and you can do this as well. I'm going to change the axis so we can clearly see negative 6 is the lowest. So let's make that, say, negative 8, bring it in a little bit. We'll make this go to 20. Okay, so this is just basically changing the range or the domain of our x values, what we can see on our grid. So I can change it from 20. Let's bring it back to 15, just because I can see the other x-intercept is at 10. I'm going to change the y-axis. We can't have negative money, so let's just make it negative 1, just so we can see it go down a bit. And then we're going to bring this up to, let's say, 2000. Okay, so now we can see it a little bit better. So in some cases, you might have to adjust using kind of these settings in in Desmos. So going back to the questions, in how many cases would the student council have to sell to make 1,375? So if I look at my graph, and we'll go back to the graph for a second. Oops. If I look at my graph, right, the y value is going to represent the revenue. And the X value is going to represent the number of cases. So if I'm looking for 1,375, when I look at my graph, and the nice thing about Desmos is I can click and kind of drag and I can see the coordinates. So I am looking for when the Y value is 1,375. And right there, I see it. So that point is at 1,375. So I'm going to go back to my graph just to kind of put it on there. So at 1,375. And now I have enough information, or I have my point to answer that question. So how many cases would they have to sell to make $1,375? Well, they would have to sell 5 cases. Because that is the X value, or the number of cases associated with that revenue. They would have to sell 5 cases. What is student council's maximum revenue, and how many cases would they need to sell to make this revenue? Now I can see that point on my graph here. I don't have to go back to Desmos. If you wanted to, the nice thing about Desmos is some of those key points like the vertex or the axis or the y-intercept or the x-intercepts usually show up as a value or a little button or a little dot that you can click, and it keeps those values there. Right, so we can see here and say, okay, my maximum revenue is going to be $1,600, and the number of cases is going to be 2, because that is the point 2 and 1,600. We can see that here as well. 2, 1,600. So when we go back, what is the maximum revenue? The max revenue is 1,600, and they need to sell 2 cases to get that. How many cases would they need to sell to make $0 in revenue? So again, that is, we're looking for a revenue of 0. Here we see 2 points where the revenue is 0, at 10, 0, and at -6, 0. However, can we sell negative cases? In this case, we can't. We can't sell negative cases, so we're only worried about the positive x-intercept, in this case, which would be 10. So they would have to sell 10 cases to make 0 revenue. Basically, they're spending as much as they're going to make. And we can put down ignore -6. We can say can't sell negative cases. Right, so very similar to why we weren't looking at the negative time. In the previous one, we're not looking at negative cases here because we can't sell negative cases. Last example, the Wheelie Fast company makes custom skateboards for professional skaters. The company models its profit with the function PB, or P at B is equal to -2B squared plus 14B minus 20, where B is the number of skateboards produced and in thousands, and PB, or P at B, is the company's profit in hundreds of thousands of dollars. Now, those two little statements are key, right, when we're talking about our answers or what our values tell us. It might be just 1 or 2, but I mean, it actually means 200,000 or 2,000, depending on what we're looking at. So how many skateboards must be produced for the company to break even? Break even may be a new term, but essentially that means that our profit is 0. Right? So break even means we need to make a profit of 0, right? Because all the money that we're making is the same as what we're spending. So our profit is 0 when we talk about break even. Now, if I look at my graph here, I can see, well, the Y value is going to represent the profit. The X value is going to represent number of skateboards. So in this case, when this profit's 0, I do see two scenarios, right? 2 and 0 and 5 and 0. So you might be inclined to say 2 and 5. However, we have to keep in mind that for the number of skateboards, those values are represented as the thousands. So 2 actually means 2,000 and 5 means 5,000. So 2,000 and 5,000 skateboards produced will equal 0 profit. So basically you get to think you need to be making or selling at least 2,000 skateboards to start before you start making profit. After that, your value or the amount of money you're spending making them is going to balance out with how much you're selling. So that might be something useful to know in business, because then you know, okay, if I reach or if I start selling closer to this amount, I can probably change the price to make more money, and so I'm not losing money or getting a lower profit. How many skateboards does Wheelie Fast Company or Co. need to produce to maximize profit? So anytime we're talking about maximizing or minimizing, we are looking for the vertex. We can see the vertex here is at 3.5 and 4,500. Or not 4,500, sorry. 4.5. So when we're talking about how many skateboards do they need to produce, remember 3.5 is actually represented as the thousands. So this is 3,500. 3,500 skateboards need to be produced to maximize profit. Now, it doesn't ask us how much profit, but if we wanted to just kind of add that in there. So max profit in this case is 4.5. We have to remember that 4.5 represents hundreds of thousands of dollars. So it's $450,000 would be our max profit, or 4.5 hundreds thousands of dollars. So in this lesson, the main thing is just understanding how we're using a graph, or how we're looking at a graph of a quadratic to help us answer some questions, right? Looking for either X values or Y values, or finding the associated X or Y given one of the other values. So make sure you know some of the key terms, right? Maximum, minimum, right? Breaking even is it means 0, right? And just think about what the graph is representing, and what do the numbers tell us in reference to our scenario.